Welcome, ladies and gentlemen, to the Technical Forum of Hydrogen and Fuel Cells Europe at the Hannover Fair 2022. We have a lot of very interesting presentations, and today I'm proud to have a senior scientist here from the Fraunhofer IFAM. This is the Manufacturing Institute for Manufacturing Technology and Advanced Materials. And he will talk about POWERPASTE, hydrogen for backup power and mobile application. Please welcome with a clap Dr. Marcus Voigt.
Thank you very much for the kind introduction. And indeed, I will be talking about POWERPASTE both for backup power and mobile applications. And we've been featured both in the press as well as even on national TV in the last year quite a bit with our technology. And basically, it focuses on one big problem which you have with batteries. With batteries, you all know you have quite low specific energy and energy density and only limited durability and high self-discharge. And you also need charging infrastructure. And last but not least, you have high capital expenditure per kilowatt hour. And POWERPASTE addresses all these issues, so you have very high specific energy densities and specific energy, and a long shelf life and nearly no self-discharge, and also very low capital expenditure per kilowatt hours. On the other side, of course, it's a technology which is not yet at the market level, but we achieved to increase the technology readiness level to TRL7 within the last 3 years, and we think it might be a quite competitive technology even for the near future. It has advantages over other technologies like compressed hydrogen, diesel generators, or methanol in combination with direct methanol fuel cells as well. For example, you don't need compressor, you don't need expensive infrastructure, which means hydrogen filling stations, and of course also no high pressure tanks. And on the other hand, you have the full spectrum of advantages of hydrogen, which is it's completely emission-free and low maintenance costs for the use. And instead of having a toxic material, it's completely non-toxic and non-volatile, so you can use it indoors as well, and you have the advantage of very high power densities with POWERPASTE. And of course, most important, we think there are certain applications where even in the near future, the total cost of ownership with POWERPASTE is lower in comparison with all other technologies. Here's an overview over specific energies, which means energies per weight, and energy densities, which means energy per volume of POWERPASTE in comparison with other technologies like batteries, for example, or methanol with direct methanol fuel cells, or even small generators. All these numbers include conversion losses and are realistic electrical specific energies and energy densities. We think there are certain entry markets for power systems based on POWERPASTE. So firstly, stationary systems, mainly backup power systems. I will talk about them in a couple of seconds, but also portable and mobile systems. For the stationary systems, mainly the low capital expenditure per kilowatt hour and low maintenance costs are the most important factors. And for the portable and mobile systems, of course, they're very high specific energy and energy density, and the ease of use, of course. So how does it work? Basically, you mix PowerPaste with water in a hydrogen generator, also sometimes called a reactor, and you produce hydrogen and a non-toxic byproduct, and the hydrogen is directly fed into a fuel cell, which can then power any electrical load, for example, a motor or any other load. And here you can have a look into the reaction. So here you can see actual hydrogen bubbling inside this glass reactor. Of course, in the systems and the system we demonstrate here, this is a stainless steel reactor. So maybe some of you haven't heard about PowerPaste so far. It's based on magnesium hydride and made into a paste form. But unlike commercial magnesium hydride, which nearly doesn't react with water at all, it reacts very fast and very complete. And also, you don't need any special water for PowerPaste to react. So you can use water which is locally available, and the technology basically dates back to the year 2013, which we were back then awarded the EFSEL award for our fundamental science behind this. So the formation of dense passivation layers are inhibited with certain additives and the paste form, and we also published the results. And when it comes to the production of PowerPaste, it is actually quite simple. You start with magnesium powder, you add hydrogen, then a metal salt to make the reaction fast, and a so-called ester to make this paste-like form. And when talking about production, quite a bit has happened in the last 3 years since I've been last here. We are building a pilot plant at Fraunhofer in Brunswick, and it will start production later this year. And basically, we optimized the whole process chain of hydrogenation here in the lab scale, here in the actual pilot scale, the wet milling, also lab and pilot scale, and the filling into various kinds of cartridges. Here at this year's Hanover Fair, you can have a look at our prototype power generator for backup power applications, which is basically a 500 watt continuous power output system with 1000 watt peak power of the hybrid system. And basically it's a continuously operating system by using 2 cartridges which are alternated, and it's based on an open cathode PEM fuel cell. And of course, in the future, we plan to increase the power output for these kinds of systems as well. But also some development has happened in the area of lightweight mobile applications. So we developed a very compact and lightweight media systems containing everything. So the PowerPaste, the water, collecting the byproduct, combining everything with the fuel cell. And these are actually estimates, but good estimates, what we can achieve in the next step as an overall specific energy on a system level, and it's nearly 300 watt-hours per kilogram, so basically containing everything, also a fuel cell, and there's lots of potential for future optimization here. Also, in the area of background IP, there is an update here. So all patents, both for the system technology as well as the paste, have been granted meanwhile. When it comes to the life cycle assessment, we think PowerPaste is really a sustainable solution for hydrogen necessities if the magnesium, which is the starting material, is produced in the right way. So if the magnesium is produced by molten salt electrolysis of magnesium chloride, the achievable amount of efficiency is very high. So you need 7 kilowatt hours per kilogram magnesium, which is close to the theoretical minimum of 6.3 kilowatt hours per kilogram. And the other process steps don't include that many losses. So when doing a very quick and very rough power-to-power calculation, which is of course not so easy to do because you use different substances where you start and where you end. But you can do such a rough comparison. You end at a total efficiency of approximately 30-31%. And in comparison with other technologies, like for example compressed hydrogen and including the compression losses, it is, in our opinion, quite competitive also for future markets, not only for these niche markets I've been talking about today. So thank you very much for your interest. I'm looking forward to you visiting our booth A68. It's just over there. And now I'm looking forward to your questions.
Thanks a lot for this presentation. I was talking to the next speaker, but we have some time for a question. Are there any questions from the audience? Some special information about the paste?
Maybe a silly question. When you finish up the paste, how can you use it? You just change the paste, or
Yes.
you need to change the whole system because you have water, right? Your water was get somehow polluted into the chemical hydroxide.
Yeah.
Do you have to change the whole system, or?
So basically, you change the whole media system, so replenishing the water in the paste and removing the byproduct, which is magnesium hydroxide. And for these very compact applications, we've integrated we've built a completely integrated media system which contains all three fluids, and we also made some first efforts of recycling this byproduct, and it looks very promising. It can be done quite easily.
No more questions? So you're invited to come to his booth.
A68.
Okay, say it once more.
A68.
A68. Thanks a lot, Dr. Marcus Voigt.
Thanks very much.